Welcome to Unit 1.7b, GCF and LCM with variables. In the last lesson, we talked about how the greatest common factor should always be less or equal to the original value. Always think factor, F, fewer. And when we talk about the least common multiple, should always be more or equal to the original value. So if you think multiple, think M more. But now we're going to start talking about how these apply to variables. So when we look at the greatest common factor and we think less, and we are trying to find the GCF of an x squared and an x to the fifth, we want to think less. Think the lesser one. So that's going to leave us with x squared. If we look at y to the third and y to the third, well, they're the same thing, so it's y to the third. And if we look at z to the fourth and a to the eighth, well, now we're looking at two completely different variables, so clearly they do not have any common factors. So in this case, we would look at none. Because remember, a common factor would have to be in both of them, and since it's not, we have nothing there. Whereas if we look at least common multiple of these same ones, and we're looking at x to the squared and x to the fifth, we are looking for the one that's more, because it should always be bigger or more than. So that's going to be x to the fifth. Now y to the third, that's going to, again, since they are the same, be equal to. So we're taking y to the third. And if we're going to try to find the least common multiple of two different things, and now we have z to the fourth and a to the eighth, well, we need to make sure least common multiple they have would be z to the fourth, and if we look at a to the eighth, that is going to have to be a to the eighth. So that's just going to be a little intro to some of our bigger problems. So let's take a look. So when we take a look at example 1, and we go about trying to solve for the greatest common factor and least common multiple, we still got to look at our numbers just like we did in the past lesson. And, best method, maybe looking at our ladder method, what can we divide? Well, in this case, it looks like 4, and that would leave us with 3 and 4. Well, right here, just like yesterday, we're kind of thinking, all right, 4 is our GCF, and if we look at our least common multiple, that's going to be everything around the outside, so that is going to be a 48. The key here now is to take a look at our variables. This is going to be the new part. So when you look at x to the third and x to the seventh, and we're looking of greatest common factor, remember, we're thinking fewer. So x and x, we're going to take the fewer one. If we look at y and no y, well, there's nothing, so that's fewer. And if we look at z to the fifth and z to the third, take the one that is the smaller, or the one that has fewer exponents, so z to the third. So that is going to be our GCF. When you look at your least common multiple, this is looking for more. So if we look at x to the third and x to the seventh, we're taking the 7. Y squared or nothing, we are taking the y squared. And z fifth, or z to the third, we are going to take the exponent of 5. So there we are with GCF and LCM. Okay, let's take a look at a second example. Again, start with your ladder method. We want to figure out our number. So greatest common factor between a 12 and a 14 appears to be a 2. So if we divide and say 12 divided by 2, we get 6 and 7. So if we're looking at GCF, we have a 2. And if we are looking at our least common multiple, we are now looking at a 2 times 6 times 7. So that is going to be an 84. Now, again, with the new stuff here, is going to be comparing our values. So if we look at the GCF of m to the fourth and m to the fourth, we are looking for the fewer one. And since they are the same, we have m to the fourth. And if we look at n and n to the third, well, we have 1n. We're taking the fewer for factors. If we are looking at the least common multiple, we are thinking more. So m to the fourth, m to the fourth. Once again, this is the same, so we're sticking with m to the fourth. But in n and n to the third, we're taking the greater one. So n to the third. So there we are with our GCF and LCM. Okay, take a few minutes here to solve the problems in practice 1.7b before we move on and check our work. All right, good luck.